So we will resume our lesson today by investigating the hardness of water. So you get a chance to see what ions cause hardness of water. So these will be your materials here. You'll have a source of distilled water. You use 1 mole per liter of each of these guys here: magnesium chloride, calcium chloride, sodium carbonate, and sodium chloride, because you want to have sources of magnesium and calcium ions here, okay, to show the effects on soap. Then you have eyedroppers, test tubes, test tube rack, soap solutions, and detergent solutions. So what do we do? You have 4 test tubes. You label them: 1, distilled water; number 2, magnesium chloride; number 3, calcium chloride; and the 4th one, sodium chloride. So this one doesn't have anything inside, right? So what you'll do in the first test tube, you pour 5 milliliters of distilled water into it, in the one that's labeled 1, okay? Only distilled water that one will have. Then in the other 3, in these 3 here, test tube 2, 3, and 4, you pour 4 milliliters of distilled water. Then now look what happens. You will pour 1 milliliter of each of these here, and you pour that inside these labeled test tube here. 1 milliliter of magnesium chloride is going to go into this one here, calcium chloride there, and 1 milliliter sodium chloride here. Next, we take an eyedropper and you pour 4 drops of soap solution into each of the 4 test tubes. You stopper them and you shake vigorously. Who wants to make a prediction of what you might see? Okay, make it, keep it yourself. This was the result. That was test tube 1. That was test tube 4. That was test tube 2. And that was test tube 3. This one here was distilled water, and that one had sodium chloride inside. What do you notice about the degree of lathering? Test tubes 1 and 4 give the most lather. Not so test tube 2 and 3. So let's say somebody didn't, your teacher didn't label these, right? And he carried out that activity. How would you have known which of the 2 contained magnesium chloride and calcium chloride? You look at the ones that did not have so much lather, right? And this, either of these could have been the distilled water or the sodium chloride. So you can see the point that we made. Because of the presence of magnesium and calcium ions there, you can see these are a little bit cloudy. One would expect this to be a little bit more cloudy if it's truly precipitate. They precipitated out the soap molecules, and therefore fewer molecules are there to create the lather, as you've seen in test tubes 1 and 4. Okay, so I hope you understand that there. Okay, and then what I give students to do, I'll just give them this table there, describe what you observe, and give them some questions to answer on that. Okay, you can see that which form the most lather, which the least lather, which see precipitate, blah blah blah. All right, next we will do exactly as we did in procedure A. You get 4 of these test tubes and you label them again: distilled water, magnesium chloride, calcium chloride, and sodium chloride. Again, you pour 5 milliliters of distilled water in test tube 1 and 4 milliliters of water into each of these, okay, separately. Then you pour 1 milliliter of each of these into test tube 2, 1 milliliter of that into test tube 3, and that into test tube 4. But now look what happens. We're not putting in soap now. We are putting in sodium carbonate solution into that. Okay, 2 milliliters of sodium carbonate into each of these 4 test tubes here. Anybody wants to make a prediction as to what they will see? Do you remember something about when we want to soften hard water? Second method? Yes. When you pour carbonate ions in in the presence of magnesium and calcium ions, they form white precipitates of calcium carbonate and magnesium carbonate. So, what do you expect? What do you expect to see? That's what you'll see. Magnesium has been precipitated, calcium has been precipitated, the ions are precipitated. Do you think there will be any calcium and magnesium ions remaining there if you pour enough sodium carbonate? If you said no, then you could be right. Okay, this is the excess reagent, then only calcium and magnesium ions would be expected to be precipitated out of solution. This is what we will do now. We will now use this very sets of test tube here now, and we'll pour soap into these and shake up. What do you think will happen now if we pour your 10 drops of soap solution into each of these and shake up? Do you think we'll get the same result like what happened here? You think that, or it'll be different? What do you say? Okay, hold your answer and see what is going to happen now. Whoa. These lathered up like in the first experiment, for procedure A. Well, look what happens. These ladder up exactly the same way like these. Why do you think that happened? Because in these, all the calcium ions and all the magnesium ions are gone. They're in the form of solid precipitate at the bottom here. So there's nothing there to interfere with our soap. That is why you see equal lathering. The water in these two have been softened by the addition of sodium carbonate to it. Okay? But look, it's a nuisance here. You have a lot of white stuff there. Students are then asked to complete this observation table and answer the following questions. You can do that if you want. Finally, procedure C. We do exactly the same as procedure A, but now instead of soap, we pour detergents into each one of them. What do you expect? What did we say about use of detergents? We mentioned that these detergent molecules do not react with calcium or magnesium ions. They're not precipitated out of solution. Okay? So what do you think will happen? Do you think you'll get any precipitate? Do you think when you shake them up you get equal lathering? This one here, magnesium and calcium there? Alright, that's the answer to your question. Equal lathering, alright? Because these guys inside here do not interfere with detergent molecules. And that's it for soaps and detergents. Okay? And there's some questions there for you to do. Alright? Some extension questions there. You can do that. The answers to these are in your solution manual. Oh, temporary hardness, spoken about that already. When the calcium are in this form here, bicarbonate, you can just heat that to cause it to decompose, forming calcium carbonate, which is precipitated out of the water. In this way, the calcium ions are locked away, preventing them from affecting the soil. All right. And of course, you have all these true and false matching questions here. Matching question, true or false, lots of multiple choice question there. Okay. All right. These are repeated in the solution manual and the answers are from there.